Tonight on the plate we have, on the menu we have Parity. Several talks about Parity. It's been a very long time since we wanted to have Parity do a meetup with us. So we are very happy that they are present today. And Randy from Snips is going to also come and present his project for AI and blockchain. And before we start, I'll let Jerome here give us a couple of words about Talan.
Merci. So we are happy to welcome the ASSETH for another meetup. This is probably the fifth or sixth time we've been doing that. Really happy to see you all here tonight. So we're just a big group of, sorry, the slides are in French. I wasn't expecting English content. So basically we are about 2,000 people by the end of the year, spread worldwide, although there's a lot of people in France in multiple cities. And we are working on four main technology levels, which are quite similar to many people, I guess. IoT, big data, artificial intelligence, and obviously blockchain, which is the reason why we are really happy to host all of you. I'm part of a specific entity, sub-entity somehow, called Talan Labs. Some of you may have, last month, we had a meetup here as well, where we were talking about a short presentation about the Talan coin, which was already also done at the HCC conference. So yeah, I will just give the mic really shortly. We've got some few stickers if you want so. Obviously, we are recruiting as many people, I guess. So you've got some few information there, and I'm not sure who is the first to start, but please. Thank you.
Hi, my name is Maciej. I work at Parity. And this is kind of like a product showcase slash a bit of storytelling. Basically, at Parity, we have like a kind of a problem that we build a lot of things, and people don't necessarily know that we build things. And occasionally, we get asked questions like this, and one of the questions that actually happens is like, hey, wouldn't it be cool if there was an app that could turn your like phone into hardware wallet, and we could maybe like use something like QR codes to sign transactions or receive transactions, and it's like, and yeah, it would be cool. Like, and the answer usually is like, we've already built it like last year or whatever, like whenever we build the thing. So the problem is like, okay, why doesn't anyone know about it? Like this has been an app store for months and months and months. And what it is basically, it's an app, it's a React Native app, so it works on both iOS and Android. All the crypto stuff is actually Rust code pulled from the Parity Ethereum client. So it's the same kind of like cryptography that your like normal Ethereum node is running. And the important thing is the app is completely offline, which means the app never actually pulls any data from the internet. And the intended use for the app is that you get on like an old phone or just a dedicated phone for it. You download the app and then you put the phone into like flight mode or put it offline forever. And then you create an account on the phone. So your private key stays on the phone and never touches a device that's connected to the internet. And the only means of operation is that you exchange the stuff with using QR codes. Actually, you can show it off a bit. Actually, should we go? Oh no, okay. Maybe further. But yeah, okay. So why doesn't anyone know about it? So why need? So this is a tile from the Parity wallet UI, and that's like all the information you have in the Parity UI. So there's kind of like a pictogram of a phone with a log and an external account, and there's like no mention of the app in the Parity UI as this. So like if you don't know it exists, like it probably doesn't. So yeah, the UX could have been better. So we thought, okay, let's just, if we just get asked about it, like maybe we should just like fix it properly, and maybe we can try to like spread the word about it a bit. So what we figured we can also do is like to get it more widespread, to get it integrated in like a more popular wallet than like more end user connected wallet. So we figured like MyCrypto is probably a good good candidate here because it's like super like user-ending wallet, super popular. It actually solves their issue because MyCrypto faces like a lot of issues where the size, people make copycats of the site with like maybe a bit different URL or whatever, and then tries to trick people into uploading their private key to the website, and then they lose all their money. So having like a hardware wallet obviously is a better way to do it. And for us, they also had like a very fresh version that was in beta at the time. Now it's actually released. And the beta is a complete rewrite, and it's all TypeScript, which is nice because we like type systems. And it's React, which is also nice because we build all the stuff in React, so I don't have like look into like regular JavaScript with Angular and try to figure things out. It's okay. I guess now I can maybe just show how it works. Okay. So there's the party dial. I have to allow my webcam, and it works. Okay. So I have my signer here. The one thing I will do though, I will change my network from Ethereum mainnet to Coven because I don't have real Ether here. That would not be safe. Okay. So I have my account here. There is a QR code with the address, and I just scan it, and there we go. I have some Coven Ether right here. And the fastest thing I can do is just copy the address over, send myself 3 Ether, send transaction, and now I get another awesome QR code. So this thing is the entire transaction encoded as RLP. So yeah, it's basically the exact same thing that goes over the network when you send a transaction, minus the signature, which you can't have, obviously. So I just scan the thing. And now the important thing is the app shows me actually the transaction that I'm making. So I can verify on the phone that I am really sending 3 Ether from which address to which address, at which gas price, at which nonce, and so on and so forth. So I can just over here, enter my PIN if I have one. And now I get a QR code with a signature, which is just the regular SIGP signature. So I just click scan. And there we go. And I can confirm it here. And it's sent. And I can go to HScan for Coven. And hopefully it will get mined in a while. If the Wi-Fi is good. Okay, well, it's pending, so they already got it in the queue. Oh yeah, that's roughly how it works. So you have your phone, ideally offline phone, that's dedicated for this purpose. Maybe you just upgraded your phone and you just have your old phone lying around being useless, so you can just repurpose that for a hardware wallet. There we go, it's mined. Okay, so the way this roughly happened is like in February, I had an issue. I asked like, hey guys, do you want this app? Do you want to use it? And the answer was roughly, oh, did I make it small? Yeah. The answer was roughly yes, we want it. TalanLabs. In March, I opened the first PR, and then in April it finally got merged, and we got this magic Parity Signer tile next to the ledger and trezor. Very important thing, we have a wiki, so you can actually read about it, and you can like have like guides on how it works. The wiki also includes how to do it in Parity wallets, so it's not just the MyCrypto stuff. Hopefully we'll get some more adoption. Actually, it was 2 weeks ago was Toronto. We also talked to like people from MetaMask. They're also like very happy to implement it, except they like their infrastructure doesn't really predict having like types of accounts, so they would have to do a lot of refactoring. But like I think it seems they're kind of keen on doing it. So that's roughly where we're now. So this app has been out on the app stores for months and months and months. But we also like figured we can do better. So we're doing a new rewrite, actually. If you come later to talk to Alexei, I can show you like the new build. But yeah, we have new branding. So the old icon that you have on App Store right now is this weird key, which is, I believe, just a free icons from somewhere. So we have like a new icon that is like roughly the Parity logo, but it's a bit more used to like being precise with small sizes. You have the new UI, so the new UI is going to look roughly like this. Scanner, and we have some more features for it. So one thing that's coming is the signed transaction. So we cannot show you the actual like, transaction history because again, the phone isn't pulling in data, but you can at least see what you have signed on the phone as it is. That's one thing. Another thing we figured out, okay, right now there's no like network indication on the app. The app actually works on any like Ethereum like network that supports stuff like MyCrypto. So you can use it on, you can use the same account on like mainnet and Opston and Govan and all the other networks. But what we found out is people don't actually know that they can use the same private key in multiple networks. Like the assumption was that this is made for the mainnet and no one knows. So we are actually adding this primarily as an education that, okay, you can actually use it for multiple networks. And as a second thing, we can also check the chain ID from the transaction you're signing. And if you created an account specifically for like a mainnet and you're signing a transaction not for the mainnet, then we should at least warn you about it, right? We should like tell you which network the transaction belongs to, and if it's not the network you expect, then maybe you shouldn't sign it. And last but not least, there's like on all the screens there's this secured in the corner. So we were also like trying to show you how to use it directly in the app without having to actually read documentation, because yeah, who reads documentation, right? So basically the app will check whether there is wireless access, and if there is wireless access, it will show you that the phone is actually insecure. So you have like a big red warning on every single screen in the app that you're not actually using it the way it's intended. It will still obviously work, but just to be educated. So for this, there's the link to the wiki. Yeah, MyCrypto link is still to the beta. The beta is off. Like you can just go to the regular MyCrypto, and because like it launched, when it launched like last week, roughly. So yeah, it's on MyCrypto. It's pretty new as well. So yeah, that's it. Are there any questions?
Yeah, what about the QR code? Did you manage to fit the data in the QR code?
Yeah, so you can sign a contract transactions. I'm not sure. So the QR code scales to the amount of data. It just gets more dense. So I'm not sure actually what the limits are of like how much data it can do. But like regular like ERC20 tokens, you can send stuff. The only problem is like the app doesn't obviously know anything about the contacts you're calling. So the data is just going to be like hex code that doesn't necessarily mean anything to human. So we are thinking about some ways to do like something about it. So maybe like if you use some UI that knows about what the ABI is, maybe that UI can tell the phone what the ABI, like the expected ABI is for a contact call. And the cool thing is the phone can actually verify that the call in the data is actually matching the signature because of the schema. Like there is the types and the name of the functions are hashed and then truncated, so it's maybe a bit easy to attack. But there's at least some level of security where you can actually verify that the data you're sending is the data, so we can actually see like maybe the data type. And I guess for things like maybe ERC20 transfers, we can build it in somehow. Yeah. Yes.
I think there is still quite a big, large attack surface.
Mm-hmm.
For instance, when you plug the phone to recharge it,
yeah.
It can be plugged to a fake cable, and
yeah.
it got updated in terms of firmware. At some point, I'm sure you are going to want to update the software that you loaded on the phone, and again, it will be a vector for attack.
Yeah.
Also, the phone itself can be unlocked. If someone is observing you, you can see how you unlock the phone. So it's better than nothing, but I think it would be good to position it as not so secure.
Yeah. So in the order of questions. Yeah, in the order of questions. So Yeah, so one thing actually we are going to put in the App Store is a user guideline on how to use it. And one of the points is like you should never plug it into anything other than like your manufacturer's charger into the power outlet. Like you shouldn't like put it into like random USB ports. Maybe airports are fine. I don't know. But like you should like watch where you're charging it. What were the other two? Oh yeah, so like the only software. The hard drive or SSD on the iPhone, I think, is encrypted by default. On Android, you can make it encrypted. I think the new version is also encrypted by default. There is a pin on when you're sending stuff, so it's got that security. But yeah, like.
Sorry, maybe I was not clear. I was not talking about updating the phone operating system.
Yeah.
I was talking about operating your app.
Yeah. Well, so the app should work forever, like for quote unquote, right?
Feature that people would want.
But you can download APK and just like update it from your laptop, from your secure laptop. So just copy
How
APK.
the phone is going to verify that the app that you are going to sideload is the genuine app.
You can build yourself and install it.
And you can review. Yes.
It's like if you're like, it's the same with like ledger firmware. Right, yeah. What's the difference?
Not exactly.
If you're concerned about security so much, you can do your, like a lot of things to make sure.
You don't need to update it if you're not worried about the like for example the firmware as well. Like so consider that that has the same option.
Yeah. Oh, ideally, what you can also do is you could probably just do like a complete like factory swipe of the phone, and then update or download the new version, put it offline again, and then restore the account from a phrase. Roughly, right?
You need to trust the application because it's offline. It's like you don't trust lecture, for example, if it's offline.
Of course I need to trust the application, because if the application is going to make fake transactions on my behalf, and I'm going to approve them.
Yeah, but the application doesn't make transactions. Like the
What you can do, you can sign the QR code, which is your show, which QR scanner from different device and see what's showing.
Yes, because in the application there is a big red warning saying, "Oh, verify each and every digit before."
You can do it if you need this. If you're paranoid, you can do it.
Once again, it's no different from ledger. So packet ledger firmware will sign all the different address transactions, then you will still have to verify.
I would say it's just reasonably more difficult to hack a dedicated device than to hack a phone. I mean, if you are just considering physical attacks, dumping the memory of the phone is trivial. I mean, if you get physical access to it, it's completely trivial to dump.
Yeah, I mean, sure. Like you always like have like security vulnerabilities and issues with this stuff, and especially.
So I don't want to be harsh.
Yeah.
And I want to be, my entire point was to say, don't present that device or that app as high security, because it will bite you.
Yeah. It's.
Like liability.
At first, better to see what the app first, because also we not only encode the storage, we also encode the keys inside the storage with your PIN, and like there's double security. You can encode with the PIN code.
So you say that dumping the memory isn't actually useful.
Because by default we sign it with PIN code also. Maciej saw it, but you should unlock first.
And from the PIN code to the encryption key, you are using something like PDF,
I think it's the same. Yeah, it should be the same. So yeah. And anyway, yeah. The point is like, the app is made so that you should not have to update. Like you should not be forced to update. So like any new features we're going to add, we actually don't want to make like a lot of releases. We just want like make a hopefully one release and leave it, and not have to touch it unless there's like really something changed on the Ethereum protocol itself.
I'm also very open to hear like any suggestions you guys might have how to improve that situation. The code is open source, so you can contribute or just talk to Maciej.
Yeah. Yeah.
You mentioned in the app you can't have all the history of the TXs because you're not connected to the internet.
It's not all the history, but.
Wouldn't there be a way to include them in the QR codes once you sign a transaction? Gets all the transaction in and out.
Yeah.
One of the QR codes.
Yeah, so we are actually thinking about doing something that where you could like sync the history. So like if your like online wallet has the ability to like fetch the history for your account, then maybe you can like sync your Parity Signer app with the QR code, fetching some from some UI. The problem with that is you kind of have to trust it, obviously, and I'm not necessarily sure if this adds super lot of value, but yeah, we were thinking about it. The main problem here is like if you have like a super long history, then maybe it doesn't fit in again. This is a similar problem to data. Maybe you need to like do like a stream of QR codes or something. So I don't know, technically possible, kind of interesting maybe, but like we have some other features we also like want to get in first. Yes? Okay, let's give floor to Andre.
Hi everyone, I'm Andre, work at Parity, and I'm going to give a talk about Pluggable Consensus with the Parity client. So Parity is an Ethereum client, but we usually call it like Ethereum Plus because we have some extra features that are not part of the mainnet, and we have a really big focus on making sure that the client it's pluggable. So the networking code is pluggable, the VM is pluggable, so we support EVM and also WebAssembly, and we also have pluggable consensus engines, which is what we're going to talk about. So what is consensus on a blockchain? So we want to send transactions that requires us to create new blocks, and we need to find a way to agree on who is the next block proposer. And we also need to find a way to choose between different chains in case there's a fork, which one is the canonical chain. So with proof of work, the block proposers are actually miners because they must do some work to find the proof, and that gives them the right to propose a new block. Finding the proof is a stochastic process. They are just doing a bunch of hashes with random nonces until they find one. So the next block proposer is chosen randomly in proportion to its computational power. And in proof of work, the fork choice rule is that we choose a fork. If we have two different forks, we go with the one that has the most work behind it. It's usually the longest one, but that's details. Whereas with a POA, which is proof of authority, we have a set of authorities that will be proposing blocks, and we have a consensus algorithm that will determine who is the next block proposer. After the algorithm determines, that validator can then seal a new block and broadcast it to everyone else. So in Parity, besides supporting like ETH for the mainnet, we also support Aura. It's a consensus algorithm. It's called Aura. The idea is that it's an authority round, the full name of the engine. So it works by time is split into discrete steps of a given duration. So for example, let's say 5 seconds. And a step is basically the current time divided by that duration. So at a given step, a proposer is determined, and the rule for determining it is we have like this bounded list of validators, and we just pick the node that has the index like step 5 module number of nodes. That proposer is then allowed to issue a block. So basically, the consensus itself is done by having synchronized clocks. That's what everyone is agreeing on. And then from then, since everyone has synchronized clocks, we can know that we are all on the same step and agree on that. And since we know we are all agreeing on the same step, we can have this simple rule to determine who is the validator. So besides that, the protocol also contains a chain scoring rule. The idea is that it will prefer chains that are longer, but with less gaps. That means with less steps skipped. We might have a smaller chain where no steps were skipped, and we will prefer that chain instead. And so on each step, each honest node will propagate the chain that they have seen with the highest score. Okay, so now we're going to sidetrack into finality. So finality, it's basically the idea that after a given block is finalized, it's impossible to revert it. Like even if we find some other longer chain or a chain with a higher score, or however we define it, after the protocol finalizes the block, it's impossible to revert it. So with pure proof of work, like Ethereum or Bitcoin, it has no notion of strict finality because it always follows the longest chain. So if somehow we can create a longer chain, we can basically revert whatever we want. But we do have the concept of economic or probabilistic finality, because since there's like a lot of hashing power, it's not reasonably to expect you to be able to mine a chain that's 100 blocks ahead, because you have to have a lot of mining power, and so you have this notion of probabilistic finality. So the deeper a block gets in the blockchain, the harder it is to revert it. So this is why, for example, with Bitcoin, they say that you must wait for 6 confirmations. The idea is that 6 confirmation gives you an amount of probabilistic or economic finality that you know that no people will have to spend like a lot of money to be able to revert that. But with proof of authority, we can have different finality guarantees depending on the consensus protocol. We can have like instant finality. So as soon as a block is committed, it's impossible to revert. Basically, what this means is that every time we're committing a block, the majority of authorities must agree on that. Or you can have the notion of non-instant or eventual finality. So this is maybe a bit scary, but we'll get right through it. So how does finality work in our consensus engine Aura? So we have this notion of the signature set of a given set of blocks. And so basically, for any given subchain, if the block at the head has been signed by more than half of the authorities, that block and all its ancestors are considered finalized. And so we're going to... sorry, the authorities? Oh, so yeah, basically, let me go back. So the authorities are basically some special nodes that can participate in the consensus protocol. So whereas in proof of work, you can just try, there's no coordination, you just find a proof and that gives you the authority to issue a block. In proof of authority, you have like a set of nodes that only them will be able to participate in consensus. Yeah. Actually, I don't know Dash, but... okay, so going back to this, let's look at an example of how finality works with the formulas that I showed earlier. So we will have 5 authorities, so only 5 nodes will be able to issue new blocks. And each node, each of these validators will be denoted by a different color. So the first node commits this block at step 0. So at the next step, it will be other authority that can issue a new block. So they will issue a new block, and by issuing a new block, on top of the previous one, they are basically signaling approval for the previous block. Even though there's no communication, like implicitly, you are saying that as an authority, you agree with what just happened. So the next time someone issues a new block, they keep implicitly agreeing with what you've built on. And in this case, the block at step 0 is now confirmed by 3 different authorities. And remember that we had like only 5 authorities, so this block is essentially finalized. Like no one can revert it because there's only 2 authorities left. So we have a majority that has agreed on this specific block. And as we keep issuing new blocks, the same thing keeps happening. So the block at step 0, now 4 different authorities agree with it. In this case, it doesn't really matter because we already had the majority. But now the block at step 1 is also finalized. The block at step 2 will also be finalized. Yeah. And so this idea of finality stems from the fact that a simple majority rule. So in this case, we only had like 2, we already have signatures from 3 nodes. Even if the other 2 nodes are malicious, they cannot do anything because they'll never get a majority vote. But one of the important things with this mechanism is that in order to reach finality, basically authorities need to keep producing blocks. Yeah.
How do you deal with the same problem at stake, like nothing at stake? How do you make sure that you know it doesn't go on multiple chains appears?
Yeah. So actually in this proof of authority, it's usually used for like permission chains where you have like authorities in the real world, you have a consortium of companies that have an identity. So they're not backed by any stake at all in this scenario. Does that answer your?
I can maybe expand on it. So basically, the consensus engine doesn't deal with who the authorities are and how they are selected. And there is a thing called validator set contract.
Yeah.
So if you are deploying your own chain using Aura, what you would do is that you write your own contract validity that defines which are the authorities and how they are selected, and maybe
this is a spoiler. We're going to talk about this. Okay. So, yeah, the only way that we can reach finality is to keep issuing blocks. Even if there are no transactions, we need to issue empty blocks. Okay, so as I said, since we need to keep issuing empty blocks, this would cause a lot of blockchain bloat. So instead, what we do is that if the selected authority to issue a block has no transactions at all, we just like broadcast an empty step message and signed it. All of the other authorities accumulate it, no block is issued, and we go to the next round. And basically, when an authority has to produce a block, it will include all of these empty step messages in the block that's actually mined. And these empty step messages will also be taken into account for rewards calculation. And the empty step messages will also account for finality because by issuing an empty step and the fact that it will be included in a block means that this authority agreed with whatever was done in the previous step. So that, again, they're signaling support for what happened before, so we can exploit that to achieve finality. Okay, so now I have a demo. Let's see, is this big enough? Okay, so we're gonna basically start network with 3 different authorities that will basically keep issuing blocks. Okay, nothing to see here. I'll talk about it. So you have like 3 different colors for the 3 different authorities. This will get better in a bit. Okay, so they are issuing blocks every 2 seconds, roughly. And we can see that now they've mined block 3, now they're on block 4, and every 2 seconds the authorities, the selected authority produces a new block. In this case, it's an empty block. and all the other authorities sync with that block. So we're not using the empty steps stuff here. So I'm gonna change it to okay. And we're gonna start again, but now, oh, I hope it's this one. Okay. So now nothing's happening. No blocks are being produced, but in the backstage, a new authority is being selected, and it's sending an empty step to the message to the other authorities. Basically, they will keep sending empty step messages until someone has a transaction to mine. So what I'm going to do is I'm going to send a transaction, and yeah, the authority that was selected mined the block like right away. And then again, we have the same finality guarantees. Obviously, this block is not finalized. It's the first block. But then I can send another transaction, and the new block is mined. And so this way, we don't have to deal with the bloat of always producing empty blocks, but we still get the same finality guarantees. Okay. So, as Maciej was talking earlier, we need to get some way to declare who are the accounts that can participate in the consensus process. So, who are the authorities? The simple thing is to have like a static list of addresses that never change. These are authorities that you pick, and they will never change at all. Or we can have a smart contract which the engine will query every time to know who are the current validators. So we call this smart contract the validator set, and the interface is that when you are implementing this validator set interface, whenever you want to change the validators, you basically issue an initiate change event, which will eventually be picked up by the consensus engine. You also need to provide a method to get the current list of validators, and there's a special method called finalized change, which is only called by the engine when the change that you triggered before is finalized. So why can't we right away, when we want to change the validators, just do it right away? Because that change itself, it's not finalized. So we could issue the event saying that we want to change something, but the chain could be reorged to some other fork where that event is never exists. So the contract issues the event saying that it wants to change the validator set, and when the engine realizes that this block is finalized, then it calls the finalized changes method, and then you can, in your smart contract, update internal state to represent the new validator set. Besides this, the validator set interface also has methods for dealing with reporting misbehavior. So, for example, if a given authority doesn't produce a block on their step, that's misbehavior. We call it, like in that specific case, it's benign misbehavior. It could just be offline. It's not really trying to subvert the system. But there's also reporting for malicious activity, and in that case, you also get like a proof of this malicious behavior. So if the other nodes see a given authority doing basically a double vote, so in their step, doing different things on different chains, if anyone picks this up, they can report it to the contract, show the proof, like this guy issued this block on another place, and then in your validator set, you can deal with this any way you like. So for example, if you had stake, you could burn the stake and kick them out. Okay, so earlier I said that besides dealing with who is the next block proposer, we also need to have like a fork choice rule. And up until now, the Parity engine had like a hard-coded fork choice rule, which was similar to what we had in Ethereum. So every engine that you implemented in Parity had to to have this idea of attributing a score to a block. And then the rest of the framework will always follow the chain that has the highest total score across all blocks. But this doesn't really make sense for engines that provide block finalization, because you could find a different chain that has a higher score, but that it's reverting some finalized blocks. And we should never do that. So finality should be taken into account in the fork choice rule. So what we did was we had like these two methods to the engine. When you're implementing a new engine in Parity, you have like this fork choice type where you say that I want to go with the new fork or with the old fork. And the engine itself, for example, Aura, can look at its finality information to say, okay, this block is finalized, so it doesn't matter if the score is higher, I'm going to choose the old fork. And besides that, the engine can also issue like actions. So for example, in this case, the action will be marking a given block as finalized. So the engine says, this block has been finalized, and the framework handles the rest. Okay, all of this finality stuff, it's actually needed for us to implement Casper FFG. Casper FFG, it's basically an hybrid proof of work and proof of stake system where Ethereum will keep working as it works now with proof of work, and every 100 blocks that will have validator staking that will vote to finalize a block that we call a checkpoint. We actually already have a prototype working for the latest EIP, and it basically uses all the features that I just described about the fork choice framework. Okay, then last thing, the Parity Consensus engine also allows you to do the block reward calculation using a smart contract. So we have some people that are using Parity to run their own Ethereum-like chain, and sometimes they have specific rules for how they want to do block rewards. And right now, what they do is that they either fork Parity and change the engine, or we actually incorporate that change into our engine if it's a big enough chain. So the idea is that we'll have a smart contract that will calculate the rewards. The engine will call that contract, get the rewards, and then apply them to the chain. So the engine passes this list of benefactors. So for this block, the benefactors in Ethereum would be like the block author and the uncles. So it's the accounts that are somehow involved in the production of this block. And we also have like this array of different kinds. So for example, for the first benefactor, we would say this is the block author. For the second one, this is an uncle. And then you can use whatever logic you want to reward them. Okay, so I've implemented this block reward, which is the subsidized Andre block reward, which basically what it does is you get this list of benefactors, and it basically adds my account to always receive block rewards. So I receive like 9,000 Ether for every block that is issued. This is obviously, actually there are some chains for which this exact thing is useful, because they will use block rewards to like fund the development team. So some chains actually have something similar to this. But now they can implement it without forking Parity. They just write their smart contract, configure their engine to query this contract, and that's it. Okay, so last slide, I think. The interesting thing about proof of authority is that proof of authority is a building block for a proof of stake system. So what you essentially want to do is to choose the authorities in proportion to their stake. And you can implement this logic in the validator set. You can implement a validator set contract where different accounts can just stake Ether there. You have some logic to choose which will actually be part of the validator set, and then everything else is the same. Okay, and that's it. Questions?
If I recall correctly, the
Yeah.
So it's easy to attack.
Yeah, yeah. So in the case of proof of authority, like you know that the next authority will be this guy. But for example, as I was saying, imagine that you want to build a proof of stake system on top of this, and you can say that like every 50 rounds we change the validator set. So every 50 rounds there's staking involved, the order changes, and so you can and you can also like do on-chain randomness to solve that kind of stuff. So yeah, that specific case.
Yeah, for POA,
Yeah. Even for POS, if you build on top of Aura, like it's your responsibility to shuffle the validator set. Like, and if the validator set is static, but for a small amount of time, I guess you can prove something about it. Yeah.
So, three questions going back in time from the most recent slide. So, from proof of authority to proof of stake, that's an interesting concept. However, it means that for every step you have to change the validator set. And this is done in a two-step way.
Okay.
And so it's going to slow down, you are going to waste cycles.
Yeah. I mean, from a security perspective, I don't know what is the size of the epoch. Oh, so again, the question, I have to repeat the question, which was that we will, if we have to reshuffle the validator set every single block, if we're doing a proof of stake system for security. Actually, I don't know how to answer that question. Like, there's probably like there's security analysis that you can do based on the number of validators, based on the number of blocks that you go between different rounds of staking. So, to me, no, go ahead.
Okay, maybe I'm missing something. Maybe, again, you are not in a blockchain, but you are in a closed system. But usually, if you are using proof of stake, it means that anyone can enter and put a stake.
Yeah.
And as soon as that guy has a stake in place, he wants to be part of the validation.
Yeah, but it's...
It can happen every minute.
Okay, so the question is that in a proof of stake system, we would have to, everyone wants to stake, they want to stake and be a validator like right away. But it doesn't actually, like if you stake money, it doesn't mean that you're going to be a validator on the next block. Yeah, it's true, but even that is not true. There's like these epochs where for like this period of 100 blocks, it's static, like it's these validator sets, and through this epoch, people can stake. Again, I don't, yeah.
In the beginning of the presentation, you talked about sometimes choosing the longest chain is not the right decision.
Oh, okay. So the question was, sometimes choosing the longest chain is not a correct decision. That was specific to Ethereum, where we take into account, it's not like Bitcoin, where we also take into account uncles. It's actually called the greediest observable subtree. Yeah, it's called the Ghost Protocol, where you take into account not only the length of the difficulty, but the number of uncles also matter for the difficulty.
At that time of the presentation, you were not talking about uncles, but maybe you were, and you did not mention that.
Yeah, I shouldn't have said that at all. Like.
So that one is just and on the first slide, you're talking about Unix time, and we have many versions of Unix time. Unix time isn't the same on Macintosh and on
Yeah.
and on Solaris, and each have different topologies. Which one are you using?
The one that runs on that's on Linux and Mac OS, I guess. Yeah.
If you have validators using different
That's
versions,
yeah.
you have the same time.
Yeah, actually, this is something, not only that, we actually have to synchronize the time. So we have to make sure that the different authorities are running NTP and stuff like that. So, as I said, like I'm not personally in love with this consensus rule, like because, as I said, like the consensus itself will be done by NTP, where it synchronizes time over different authorities. But in the future, we want to change so that we don't have such a reliance on synchronized time. just on like clocks beating at the same rate. And we also want to change something where even if I don't have, so for example, right now, at a given step, only the specific authority can issue a block. And if it doesn't have any transactions, it issues an empty block. But the next authority could have transactions in its queue and could produce a block with transactions. So we also want to improve it so that at each step, like I was selected to issue a block, but I don't have any transactions, but somehow the protocol allows this authority to issue a block in my turn. It doesn't happen right now, but that's where we want to go eventually.
Can maybe also try to address this. So if you have like a differences, I know like step seconds or something, you can just set the time frame of a step to be like large enough so that they should like correlate roughly.
I'm talking about Unix stacks that are really different.
Okay.
Not by a few seconds, but by a few years, because they are not encoded
Yeah.
in the same year. The years
Like different epochs
Okay,
entirely.
that should be easy, like implement on like software level to like align them.
Okay. Anyone else? Okay, then that's it.
So I guess I'm going to be talking less about protocols and things like that, because in fact, what we're working on here, we're likely to be implementing that with Parity. Anyway, so what we're building at Snips is a decentralized, private by design, open source voice assistant. Anybody familiar with Alexa? So you've probably seen that news today that someone got randomly recorded and it got sent to a random person. And the reason why this happens is because all of the voice assistants use machine learning. And so machine learning is a probabilistic method. Sometimes it just fails, right? So in that case, there was a triple fail. The machine learning failed thinking the woman was asking Alexa to do something, so it started listening. Then it actually thought that the person has said send a call or whatever, something like that. Then it failed again thinking they pronounced someone's name. So there was 3 failures consecutively in the machine learning models that made this thing record. So the point is that the moment you start using a voice assistant in the cloud, you're guaranteed no privacy. And whoever says otherwise is either lying to you or has no fucking idea what they're talking about. That's a fact. So what we're doing is the exact opposite. All right? So we built a voice assistant and runs 100% embedded on the device you're talking to. So when you're speaking to a device that has the Snips assistant inside, the device itself does the processing and no data is ever sent to the cloud for processing. And so what that means is that we've actually been able to run basically super advanced deep learning on small devices. So if you want to know exactly how it works, there's a wake word, that's a convolution neural net and a deep net together. We squeezed it down to 1 megabyte. There is a speech recognition that transforms the sound of your voice into corresponding text. So that's a time delay neural network in a LSTM. That's 10 megabyte. And then there is the natural language understanding, which is a more traditional CRF. So you can see that the platform itself is actually pretty lightweight, but you get equivalent performances to what Alexa and the other guys are actually offering. So even when people tell you need the power of the cloud to get performance, that again is completely a lie. It's also mean that our assistant is private by design. So it's guaranteed privacy because we have 0 data. We know nothing about the people using our product, like nothing. Like there's literally no data. We have 0 server powering the voice assistant. That's it. It's that simple. So we guarantee privacy by design by having 0 data effectively. It runs pretty fast, so you can run that on your Raspberry Pi. The whole end-to-end thing will take maybe 200 milliseconds. So it's actually faster than if you're going through the network with all the delays of the internet and all these different things. So the point I'm trying to say here is that, very often when people are talking about voice assistant, they're thinking about Alexa, but my goal here is to actually kill Alexa because that product is exactly everything that's wrong with the internet. It's a centralized product where Amazon has access to all of the data of every person using it. We're talking 1 in 6 Americans today. That's huge, right? Amazon as a company gives no information on how they collaborate with the government. As far as we know, they might actually be sending all of this data to government and we wouldn't actually even know that.
Amazon is completely closed source. We have no idea what's actually running in Alexa. And of course, it also actually doesn't offer any privacy whatsoever. And if that was not enough, Amazon's business model is in fact to actually monetize your data. So it's basically like, for me, Alexa is 20 years of people doing things wrong on the internet. And that's essentially what it got to, a microphone connected to the internet in your home, which makes no sense. So anyway. Ah, il s'est déconnecté. Attends, qu'est-ce qui s'est passé? Okay. We support multiple languages, so everything in green you can already do today. What's in orange is going to be coming up soon. What's in red is planned. Everything else we want to do eventually is just that, you got to prioritize. It's also open source. So we've started open sourcing it piece by piece. The first piece open source is the natural language understanding module. The whole platform is built in Rust. So it's actually also super fast. So for those of you who like Rust, this is actually a super nice piece of software. And by the end of the year, we will be open sourcing everything else. So if you don't trust us, you can actually build it yourself and you can use it yourself. So that's the ecosystem we're building on top of it. So on top of the Snips Assistant, we basically have two category of products. We've got an enterprise business that's been going for about 1.5 years. That's going great. We sell that to companies as a white label solution. On the other side, we've got a consumer product that we just announced recently that we're going to be shipping next year. And that consumer product is what I want to talk about here today. It's basically a number of different devices with the developer community building stuff on top of it and a blockchain token to power all of that. So the idea of the Snips Air consumer product is that it's basically a number of different devices which are connected together in your home. So instead of thinking about one, smart speaker, imagine having all of those different devices, a coffee machine, a TV, a speaker, all of which are connected in a mesh network of AI assistants. And so by doing that, you can ask your TV to make you coffee. You can ask your coffee machine to play music in the living room. You don't actually have to worry about how all these things are connected. And we're building two devices ourselves, a smart speaker with a CPU for processing, and those small satellites, which are effectively microcontroller-based, battery-powered small microphones. And all of that is running internally inside your house, so there is absolutely nothing happening on the internet. Everything stays local on your local network. So this is just to give you an idea of the size. So anyway, so I'm just going to be skipping quick here. Of course, we're going to be building skills. So skills are essentially voice apps. But like any platform, you want to enable developers to build their own skills as well. And so what you need is effectively an app store. And so this is a first use for us of a blockchain, because when you think about app stores, you want people to be able to monetize what they're building, which means that you need a payment system. The problem is if you take credit cards, then you have to get identities for the people giving the credit cards, and therefore you can actually attach identities with usage of what people are purchasing. And so that would kind of like not be that private. And so at least by using cryptocurrencies, we don't have to know who the person is. You can generate a new address for every transaction. You could use Monero, Zcash, something like that. There's many ways that you could actually hide the identity. And so we're looking at different ways of doing that. But it's also a great way to incentivize people to participate in a fair marketplace, because app stores are very often completely biased, right? The richer people will basically be able to be on top. Reviews are completely fake. There's all of these different issues that you can solve with good, incentives on a blockchain. So I'm not going to give too much detail here about that because it's still not yet finalized, but there's a lot of interesting stuff happening here. Now on the developer side is really where it gets interesting in the whole idea of my talk today. In order to help people build skills, we created this web interface where you can just log online and you can very easily create a skill to run on the Snips Assistant. We already have, so you can build anything you want, from voice controlled drones. So these are stuff people actually built. Voice controlled drones, smart home things, games for their kids. And we even provide a maker kit with a Raspberry Pi, a microphone and everything, so that when people don't know how to do hardware, but they want to just like build a skill for themselves, they can already do it. So you can buy all of that. This is already online. All of this is already being used. This is $99. It has everything. It actually looks pretty cool. It's very geeky, but I guess we like that here. Now, talking about the blockchain. So you've built a great skill, and now you put it out on the App Store. Problem is that machine learning is not 100% foolproof. Sometimes people will be asking something, but it's actually not going to work. So in that case, you do want people to give you feedback. And you want that feedback to be taken into account in your model. So the way this happens is you can use a blockchain and tell users, hey, tell me what you meant, and I'll pay you through the blockchain for that using a token. The problem is that if you do this, then people are just going to start randomly giving you, fake data, and then you're stuck having to manually validate everything, which kind of kills the process. So you can introduce third parties, people from the community here again, that could basically validate those transactions. And so here there's also some interesting things you can put in place to make sure that those people don't cheat. You can ask them to stake in order to participate in that. Anyway, there's a lot of very simple, interesting dynamics here. Now, this is one of the pieces of technology I'm actually pretty excited about, which is decentralized private analytics. Again, if you're building a skill, you want to know how people are using it. And if you're going to be serious about doing that, you need to know about the usage. The issue with analytics is that effectively you're asking people to send you their usage data on an individual basis to aggregate them, and therefore that breaks privacy. About a year ago, we actually open sourced a way to do analytics in a completely secure way, cryptographically speaking. And so the way that this works is using a combination of multi-party computation and secret sharing. And so effectively, the user will generate some usage data. That's going to be sent to a network of what we call clerks, so basically random people doing computing. And then this is then going to be aggregated cryptographically to send back to the user. And so the developer has no idea about the individual user data, but still knows about the aggregate population level statistic. So that works. You can go on our GitHub. There is an open source project called SDA. We've deployed that on a few mobile apps with a few thousand users as a test. What's missing still is the blockchain. One of the reasons why we didn't actually go further with this is because we didn't find a way to incentivize those clerks. You've got basically people running, computation for you. And so again, using a blockchain here is actually a pretty straightforward use case for this, and it fits really quite nicely with that model. To give you an idea, for 10,000 users, you would require to have good security about 700 different clerks, right? So, 7%, whatever number. Now, the bigger part, decentralized machine learning. So this is something a lot of people talk about. It's a super hot topic at the moment. So again, there's something called federated machine learning. The idea of federated machine learning is that each user is basically updating the neural network on its own device. So I've got, let's say, a voice assistant, and I'm using it, and I'm basically going to be updating the model itself as I'm using it. And I'm going to send this updated neural network to this network of clerks, again, who are going to be securely aggregating those mini neural networks into a meta one that's basically going to be shared. So you've got the exact same thing as before. You've got people that you're asking to give data, and you've got clerks that are asked to compute this data to offer the privacy angle. And in this case here, it's kind of a combination of the analytics part and the user feedback into one on the blockchain in terms of that you're paying everybody. So here again, it's a very, very simple piece of technology. You can use some homomorphic encryption if you really want to make sure it's super secure. So that's actually pretty nice. And it works really well. We have also a version that works with that. So anyway, so that's just to show you a little bit about the sensitivity of the data. The more data you want, of course, the more sensitive it becomes. But the issue with federated learning is that very often, people who do that assume that the users have pre-annotated data, meaning that the user will do the effort of saying, this is what I said, this is what I meant, and so on and so forth. That might work for feedback when it's once in a while, but it doesn't work for federated learning where you might be using every single query someone does as an input. And so effectively what you want in that case is to augment the data people give you with data that's generated by other people. And so this idea of data generation is also something you have a lot in crypto and blockchain at the moment, where people build those networks of workers that basically annotate machine learning data. So we've built something like that we've been selling commercially for about a year. It's not decentralized at all for now. It actually completely centralized. You pay with a credit card, and it goes through a bunch of different mechanical Turk providers. But the goal is to eventually completely decentralize it and leverage this community of people to generate the actual data. And here again, the blockchain is used for payment, but also used to make sure people don't cheat. Because the biggest issue with mechanical Turks in general is that when you're asking a random person to do a task, they just basically answer something random. And so here, by asking them to stake, typically you could try to avoid that problem. So there's a very elegant and simple solution here. Anyway, so that doesn't matter as much. To give you an idea of why data generation is so important, that's how much it improves the quality of natural language understanding. So a typical developer will use about 70-ish queries to train their AI assistants. And the reason is because if you haven't launched your product, well, you don't have data. And so what you end up doing is manually entering a bunch of examples and annotating everything, which kind of sucks. And so after a while, you're just bored of doing that, or maybe you're not creative enough. If I ask you, how many ways can you ask a coffee, you probably cannot think of 100 different ways, right? However, when you actually spread it out to a network of people, you can just give a dozen examples, click a button, and then come back later, and you can have thousands of training examples before you launch a product, effectively getting the accuracy of those things to above 90%. So for us, you see, the reason why we got interested in using a blockchain is because it made a lot of sense to build this product. From a privacy perspective, from an engagement of a community perspective, from an incentivization perspective, like if we were to do it with traditional payment systems and traditional incentivization schemes, it just wouldn't work. And so, rather than a blockchain company, we're really more of an AI company that's using a blockchain to solve a very specific product problem that we had. And so this is how we're approaching this, right? It's a tool that hopefully Parity is going to provide that we're basically going to be using to power this Alexa killer. And the good thing about it is that we already have a community of almost 13,000 developers. So we put that out. This free version of our platform was out about a year ago, not even, like I think in June last year, a year ago. And it grew organically to over 13,000 people. So it turns out that people actually love building for Snips because it's exactly the opposite of what Alexa currently is. Thank you. Any questions? I mean, obviously, I'm going to be I can be a lot more technical in machine learning than I can be on blockchain. So please, be nice. Okay.
I've got a few questions, but I like you very much. So you have the option that the others can. You do a sign like shut up, and I'm not sure.
Okay.
So my first question.
He was at the party yesterday. That's why he's saying that.
My first question is killing Alexa.
Yeah.
Imagine that in 6 months.
But do you agree on the goal of killing Alexa?
No, I agree on the goal of more privacy.
Okay, so it's the same.
And this is where I go. If in 6 months Alexa says, light appeared upon me and now privacy by design is by design and by default. And if you want to go back to the old Alexa, say the word, but now it's by default private and local process. They can do it.
So Amazon, yeah, go on.
Maybe you will have to ship Alexa V2. Maybe it will be required hardware, but it is entirely possible. And at that moment, what is your value addition? Is open source the only argument, or do you have other reasons to be better than Alexa?
So I think, to be clear, there is also a probability that might happen, which is very low, that Alexa is going to be private by design, simply because Amazon's making its money not off selling Alexa, but off using the data of people using Alexa. Like, they would need to change their entire business model. So, like, in a sense, we're kind of protected in our approach because those big companies are currently the big players, have legacy business models from the 90s that they can't just, like, shift over. I mean, they need to find billions of dollars in another way, potentially. And so that was just to say there is an economical argument that Alexa will never be private by design. Now, assuming they do offer some type of privacy, good enough, maybe the speech is on device and they keep, whatever queries on server or something like that. Then in that case, you really want to make sure that you have a strong community as well. I don't think Alexa is ever going to run on top of a blockchain. I mean, that would be such a leap forward for Amazon. Like, if you start combining every single thing, so you would want Amazon to be open source. So that's another thing, right? The fact we're open source means that people can build a voice assistant with Snips whichever way they want. We're not forcing you and sandboxing you into one very specific way, the way Alexa does. Like Alexa is effectively running Android, by the way, but you have zero access to the operating system, for example. There is nothing you can do aside from what Amazon enables you to do, which means that you're essentially forced into the Amazon vision of building voice assistants. Whereas on the opposite, we're giving you complete control over it. So I think we're philosophically so different and so opposed that, you know, if they do everything that we're doing, quite frankly, that's already a big win because it means that we will have proven that it worked to a point where it would have moved them. And so that means we probably already have 100 million users. And so, you know, it's... And it's also hard to build, by the way. There is no other team on the planet that can run machine learning on device like we do today. So, you know. Well, sure. I mean, I do believe people are going to be doing a lot more edge computing, so that's why we're open sourcing. Is I don't think our value will be in the model itself, and the value will be in building community around it. That's a strategy, right? We have a bunch of patents. We just, you know, we just use them not to protect against Alexa. We're never going to have enough money to sue Alexa, right, or Amazon. But we use it so that Amazon cannot sue us and prevent us from using our own technology. It's more defensive than offensive patents in that case.
So, going back to privacy, you said in the beginning that you don't have any data coming from the device to you.
Correct.
I understand that. However, any app developer, most of the apps, I expect the apps to be accessing the data. Because an app running locally has
Correct, yeah.
value, but
You know, you want to get the weather, you still need to pull the weather from a weather API. I agree. But in that case, the privacy is very limited to to the minimal the service is needed.
how do you know? How
That.
are you going to vet each application to scrutinize them?
Well, as a matter of fact, actually, I think this is exactly where using a blockchain makes a lot of sense. I'm not going to vet them, the community will, right? And that's something that works actually pretty well already. It's, you know,
We've seen malicious applications downloaded millions of times on the Google Play Store.
yeah, because people don't have an economical incentive to actually review correctly those apps, which they can have here.
My point is, community vetting doesn't.
Without an incentive for the community, I agree. Like, that's the key, right? Right now, there is nobody's...
Malware on your phone is a kind of incentive.
If there is a higher incentive to create a malware than to vet appropriately, people will use it.
I agree. And so, of course, you know, I mean, like, that's a problem with any software on the planet, effectively, right? Like, any software you download has the same issue. It's impossible, like, even if we guaranteed that everything on our store was reviewed internally like Apple does, which, by the way, would kind of like also not be cool because that would create a lot of like centralization of power of who gets on the App Store or not. There will all be someone who might be able to distribute that outside. You know, we're not iOS. You know, like people can actually install whatever they want on the Snips device, and so you know, it's impossible to guarantee that someone will not do that.
The App Store
Yeah.
will be hosted by your company.
Yeah, I mean, the App Store itself, but nothing prevents you from distributing it outside the App Store, just like Android, effectively.
Right, but so you must still have some screening mechanism, otherwise blatantly malicious or...
No, but there is sandboxing between the skills on your smart assistant, right? So the skills cannot access the other skills data. But like, you know, if you wanted to download the skill and install it on your assistant outside of the store, you could do that. Like,
I was thinking about something else.
Okay.
I was thinking on skills that are, let's say, racist, that have bad behaviors, and people will notice and will report and say, cease and desist, remove it. My point is, you will have to.
so, and I think, you know, this is actually also why we're still working on the token economics aspects, is because we want to make sure that that kind of behavior is disincentivized through the blockchain, ideally. I know, these are open questions, by the way. Huh? They're not, if I had all of the answers today, I would already have launched it.
Last question, if I may.
Okay.
So, the data that is going to go back to the cloud somehow to improve the...
There is no cloud. It's a network of people processing.
Thank you. No difference.
it's not the same. Like a cloud is by definition one big, huge compute power that one person has access to. Whereas here, you're basically distributing the computation on potentially everybody in the room. So you would need all of these people to collude, essentially, to break the privacy, or a certain number.
So you explained that you are using the Chameleon method
For the analytics, yeah.
Yes, yes.
So there is a threshold of security that you can choose according to how much privacy you want, basically.
Right. But this is for sharing. But to compute something, you need to reassemble data, right?
Yeah. So in the case of analytics, this is actually pretty trivial because you're effectively only summing on vectors. And so that can be done super easily. It could be done with MPC, could be done with partial homomorphic encryption. Like there's a bunch of ways that you can do that, whereas none of the actual individual user data can be seen by anyone, but the aggregation on the developer side is fine. Like there's the whole idea of MPC, right? Multi-party computation. And so this is actually published, and there is an academic paper with it. The code source is open source, it's in Rust as well. So you can actually go and check this out on GitHub. Anything else? Yeah. Oh, you did? Yes. Amazing. Thank you. You see, you're in my presentation. Yeah, was it fun?
Yes, really fun.
Super.
There's quite a delay before when we talk and when the talk tries.
Yeah, but that's because of the Bluetooth with the drone, actually. It should not be more than 200 milliseconds. But for controlling drones, like it's like voice, to be honest, is not. So funny story. We have one prototype like that at the office as well, and I had the Prime Minister of Quebec in Canada who came to the office, and so I was doing a demo to one of his team members. I was like, "Look, this is cool." So I was like, "Hey Snips, take off," and he was like filming with coffee. Then I said, "Snips, go left." And the drone smashed into the person's face. The coffee like flew. The security people are freaking out. It was mayhem. So that just basically shows that it's not a good user experience to use your voice to control a drone. I put it there because it's actually really cool to show, but it's really dangerous. So thank you for contributing to me almost getting shot by secret services. Yeah. It's been working. To be honest, we kind of even stashed it on the side because we're like, until we figure out how to incentivize the clerks, there is no real use. But we built it for mobile apps initially. And so actually the good thing about using Chameleon secret sharing is also that it makes this resilient to clerks going offline or not responding, which in the case of, a blockchain could very well happen. And so you cannot guarantee that the clerks are always available. And so you want to make sure you're robust against that. And so the privacy threshold effectively, is one way that you can play on that, And so again, there is a bunch of ways to incentivize. You can, ask clerks to actually stake, and if they're not responding, you can penalize them. There is a million ways where using a blockchain makes a lot of sense actually in that setting. So we haven't adapted this yet for, IoT. And we haven't written the blockchain part of it at all. But the actual code, the Rust code that runs on mobile has been open source for like a year or something. It's just been sitting there. We've just been waiting to have something to do with it. Sometimes we just build stuff like that. My investors don't always like it, but I think it's cool. Yeah.
In terms of incentive, do you have an idea of how much a developer would be willing to pay to get, for example, a phrase with a context and just a bit of data? How does that relate to incentivizing clerks and users?
Yeah. So I can tell you that today, our data generation service, for example, which I guess could be a proxy to measure that, we sell queries, €1 per query. And so, you need at least 500 queries to make a good intent. And most AI assistants have, 5, 10 intents maybe. So if you really want to build a super production grade, consumer grade assistant, you'll maybe be paying a few €1,000 every time you want to retrain it effectively. So it's not a lot of money. It's a lot of money if you're just a home developer just playing around. But if you're like trying to build a consumer product, it's actually not too bad. So I don't know, how that's going to translate, in a tokenized economy, right? I don't think anybody knows. I don't think anybody actually has like a working tokenized, application right now on these things. So it's part of what's exciting is actually, when you have 60 people who are doing machine learning in a company, you can actually look at this from a data science perspective as well and try to get some good answers to that, which, we're going to get over the next few months. We're probably not going to be launching, this token until like a year from now. So, we've got a bit of room to explore.
Why did you choose to launch a token, rather than using payments in crypto directly?
Just to have the flexibility for all the incentivization mechanisms effectively. And the second reason also is because we actually like the approach of using an application-specific blockchain and eventually making that interoperable with our blockchain, which is why it made sense actually to work with Parity on that. So a combination is just, Ethereum alone, like the volume of transaction you have potentially in a system where every single user query is being sent and analyzed on a blockchain, like, you're talking even with a few thousand users, tens of thousands of transactions per day potentially. And so that very quickly becomes a little bit difficult to put on a public network as it is today.
Yeah, but there are a few projects already to do MPC on the blockchain. You have
Sure.
ASSETH, you have got a few others.
I agree.
You consider using that?
So we looked at every single decentralized machine learning projects. None of them today is at the level where you can actually use it. And the reason why we're able to do it is because we're not building a general purpose decentralized machine learning system. We're actually building a decentralized voice assistant training system. And so by specializing the type of machine learning you do, you can actually tweak the machine learning side as well as the crypto side. And so that actually makes it work. If you were trying to build a general platform, there is actually a project called OpenMind, which is doing that. Super cool guy. Actually, the guy at my company who built the first version of that is now working with them, right? So like these are like super top of the field kind of guys doing that. They still haven't solved the problem. It's a hard problem, doing secure distributed machine learning is a difficult problem to solve, especially if you want to do it homomorphically, right? Anything else?
I would love to see you again in 6 months and talk about the blockchain as it is.
Yeah.
What do you think about it?
Yeah. I mean, it's going to evolve a lot. I mean, I think anybody who builds a product on top of any kind of cryptocurrency today, who assumes that they have the answers to how this is going to work, with 1 million people, like we're going to find out as we're actually trying. And that's a good thing of having already a community is we can experiment with our community and involve them in the process of trying out a bunch of things before we kind of like roll out a big consumer product. So this whole consumer product will probably not be on the market until, like Christmas 2019. Just the hardware itself will take at least a year to build. So, we're getting a bit of time. Okay. Thank you.